Title: Video Music Retrieval. An Inter-Intra Modal Loss for Cross-Modal Retrieval. Abstract: The paper proposes a novel Inter-Intra Modal loss to enhance the performance of video music retrieval models by mitigating overfitting on noisy data. This approach is particularly beneficial for self-supervised training where video and music samples are separated from the same video work, leading to false negative noise in the dataset. The proposed framework, IICLVM, incorporates the loss and achieves state-of-the-art performance on the YouTube 8M dataset. It also performs better when retrieving music using multimodal video information. Introduction. With the growing demands in the short video industry, AI-assisted video editing has significantly improved video production efficiency. The main research focus is on selecting appropriate background music, BGM, for videos using AI. Some supervised learning-based algorithms select music by matching scores of tags or feature distance in the emotional space. Recent works have treated music selection as a cross-modal retrieval task based on contrastive learning. Related work. Contrastive learning enables the model to learn various matching rules in large-scale video music datasets and reduces the feature distance between matched video music pairs. Early works performed binary classification for pairwise cross-modal samples, ranking, triplet loss ordered the similarity score of samples, and used the distance or similarity of hash codes, canonical correlation analysis, CCA, and relational network, RN, to model the cross-modal distance. Recent works like CLIP, contrastive language image pre-training, used a large number of image-text pairs to self-supervise the pre-training of two encoders for image-text retrieval tasks. CLIP was then extended to various types of cross-modal retrieval and pre-training tasks. The proposed IICLVM framework uses the global sparse (GS) sampling method for each video and music to extract the pre-trained feature sequences. The encoded features are obtained by video and music encoders, respectively. Then, the intermodal similarity matrix and the intramodal similarity matrices for video and music modalities are calculated. The intermodal loss is calculated from the matrix S, and the intramodal losses for video and music modalities are calculated by SV and SV, SM and SM, respectively. The loss addresses the issue by using the intra-loss component to minimize drastic variations in the feature distributions within each modality during training. This approach effectively mitigates overfitting on the noisy data and allows for more accurate retrieval of relevant matches without requiring complex noise removal techniques. The proposed framework achieves state-of-the-art performance on video music retrieval on YouTube 8M and performs better when retrieving music using multimodal video information. The proposed framework, IICLVM, Inter-Intra Contrastive Learning for Video Music Retrieval, aims to retrieve music for videos by learning a shared representation space for both modalities. The framework consists of global sparse sampling, sequence encoders, and an inter-intra modal loss function. Global sparse sampling is applied to extract feature sequences from video and music, eliminating duration information and enabling content-based retrieval. Separate sequence encoders are used to extract temporal information from the feature sequences. The intermodal loss function, calculated based on the cosine similarity matrix, increases the similarity between positive sample pairs and decreases the similarity between negative sample pairs. The intramodal loss function, calculated based on the similarity matrices before and after encoding, preserves the relative feature distribution of the samples, preventing false negative samples from moving away from their corresponding positive samples. The IICLVM framework is extended to IICLVTM, Inter-Intra Contrastive Learning for Video and Text to Music Retrieval, by incorporating text information, such as video descriptions, titles, or keywords. The text feature vector is used as the initial hidden vector for the BILSTM encoder, and the intramodal loss is calculated based on the similarity matrix of the features before and after the cross-modal encoder. Experiments are conducted on the YouTube 8M dataset to evaluate the performance of IICLVM on video music retrieval tasks. The results demonstrate the effectiveness of IICLVM in retrieving music for videos. Additionally, the generality of the loss function is verified on various other cross-modal retrieval tasks, and experiments are designed to verify that 2 loss can effectively alleviate the problem of false negative noise in the retrieval datasets. The research paper presents a novel framework, Inter-Intra Contrastive Learning for Video Music Retrieval, IICLVM, which achieves state-of-the-art results on the video music retrieval task. The framework utilizes a BILSTM encoder and incorporates an Inter-Intra Modal loss function to capture both intermodal and intramodal relationships between video and music features. The experimental results, presented in tables I and II, demonstrate the effectiveness of the proposed framework. The IICLVM framework outperforms other state-of-the-art methods, including CME and CBVMR, on the video music retrieval task. The results also show that the Inter-Intra Modal loss function improves the retrieval performance, with an R at 1 improvement of 0.5% to 3% compared to the CLVM framework. The paper also presents a subjective evaluation of the video music retrieval task, where human subjects are asked to choose a better music from 2 candidates for a given video. The results, presented in Table 3, show that the proposed framework acts well on background music, BGM, selection, with a probability of 88.52% that the ground truth music is selected over a random piece of music. Furthermore, the paper evaluates the performance of the IICLVM framework on other retrieval tasks, including text-to-music retrieval and cross-modal retrieval tasks. The results, presented in tables IV and VIVIII, demonstrate the generality of the 2 loss function on different retrieval tasks, with significant improvements in R at 1 performance. The experimental environment and training parameters are also discussed, including the use of a 32G Tesla V100 GPU accelerated environment and the PyTorch framework. The paper also provides details on the datasets used, including the YouTube 8M music videos dataset and the Clotho, MSCOCO, Flickr 30K, MSVD, MSRVTT, and VATEX datasets. Overall, the paper presents a novel framework for video music retrieval and demonstrates its effectiveness on various retrieval tasks. The results show that the Inter-Intra Modal loss function is a key component of the framework, and that it can be applied to other retrieval tasks beyond video music retrieval. The authors present a novel framework, IICLVM, for video text retrieval tasks, which incorporates a new loss function called Intra-Intra loss. The 2 loss is designed to mitigate the effects of noisy training data and improve the model's generalization capabilities. The framework is evaluated on various datasets, including MSVD, MSRVTT, and VATEX. The experimental results demonstrate that the 2 loss is effective in improving the model's performance on video text retrieval tasks. The authors analyze the impact of the 2 loss on the model's performance by varying the intra-loss weight, gamma 2, and the inter-loss weight, gamma 1. The results show that the 2 loss has a significant impact on the model's performance, especially on smaller datasets. The authors also investigate the effect of 2 loss on resisting false negative noise interference. The results show that the 2 loss can effectively mitigate the adverse effects of noise and achieve higher R at K values compared to the baseline model. The 2 loss is also shown to be effective in dealing with different levels of noise interference. The experimental results on the Caltech 256 dataset demonstrate the effectiveness of the 2 loss in image retrieval tasks. The results show that the 2 loss can improve the model's performance in the presence of noise and achieve higher R at K values. The authors conclude that the 2 loss is a valuable innovation in the IICLVM framework for video text retrieval tasks. The framework has shown promising results on various datasets and has demonstrated its adaptability and versatility in different contexts and applications. The 2 loss has also been shown to be effective in obtaining good retrieval models with a small number of training samples. The equations and algorithms presented in the paper are designed to optimize the 2 loss and improve the model's performance. The authors use a combination of inter-loss and intra-loss to optimize the model's performance. The intra-loss is calculated as the KL divergence between the predicted and ground truth distributions. The results presented in the figures and tables demonstrate the effectiveness of the 2 loss in improving the model's performance. The authors use R at K as the evaluation metric to measure the model's performance. The results show that the two-loss can improve the model's performance on various datasets and achieve state-of-the-art results. The limitations of the paper are acknowledged by the authors, who note that there is potential for further enhancement. The authors also highlight the importance of selecting the optimal intra-loss weight, gamma 2, to maximize the model's performance. This research paper discusses the development of a cross-modal retrieval model for music videos, focusing on the integration of audio and visual features. The authors propose a two-loss function to improve the retrieval performance by enhancing the similarity between audio and visual modalities. They also introduce a noise-resistant method for end-to-end retrieval models, which significantly improves the R at K values when dealing with noisy data. The paper presents a stacked bar chart showing the relationship between the increment of R at K with or without two-loss and the noise level in the batch on the Caltech 256 dataset. The results indicate that the R at K without two-loss drops rapidly as the noise level increases, while the effect of two-loss on improving R at K is significant when the noise level is high. The authors highlight the challenges in cross-modal retrieval, particularly in areas such as retrieval performance on tasks involving large datasets and the development of noise-resistant methods for end-to-end retrieval models. They believe that the two-loss has the potential to become an even more effective and versatile tool in the field of cross-modal retrieval. The paper also provides a comprehensive list of references, covering various aspects of cross-modal retrieval, including music video generation, audio-visual embedding, and deep learning techniques for image and video recognition. These references demonstrate the extensive research conducted in this area and provide a solid foundation for further exploration and development of cross-modal retrieval models.